And I think we're now live. Hopefully, this is working. Okay. Let's see. Make sure that I can see myself. I'm just checking out that I can actually see the light. Oh, yeah, there we go. I see it coming up now. And just want to make sure I hear some audio. And I think we're now live. There we go. I'm going to close that off. Let's close this off. Um, what is this in the stream? I see. Uh, I don't know where that you're seeing. It looks like, hang on, this and this. Okay, something is wrong here because you're seeing Xcode. The screen you're seeing is not right. Let me. Okay, there we go. That's correct now. I'm not sure why that happened. Let me just make sure that we see what's next on the agenda. I'll explain what we're doing here in a minute. Okay, great. That's coming through. So sorry about that. This is my first live stream, so there'll be hiccups. My name's Shaps, and I just crushed the mic, so that might have hurt. I apologize if it did. Never done a live stream before, but I thought now's a good time to start. I'm a long-time developer, been coding since I was about 6, so that's like 40 years now. And even professionally, I've been in the industry for more than 20 years. Um, Anyway, I haven't written a game before, but I've been very, very interested in exploring that for a long time. And I thought, they say like if you're gonna, especially with YouTube, if you're gonna start talking about something, talk about what you know, right? Then I don't have to script this, and I don't have to prepare anything. I can just switch on the camera and record, right? So that's what I'm doing. I'm gonna be very, very free with this because I just want to be comfortable. And I know that no one's watching right now. So, if you happen to see this later, which is very unlikely, um, hi, and thank you for watching this. So what are we doing? Like I said, I really wanted to create games. I want to get into the gaming industry. I am a highly experienced apps engineer, but that doesn't really translate directly to creating games. And I think also just in general, the gaming industry is very competitive. Um, but I'm finding that the apps industry is equally competitive, except now I'm competing against AI. So there's that. So while I'm out of work, I figured I might as well use this time to learn some new skills and explore things that I love, that I now have time for. And so I think, sorry about the coughing, I have been sick over the last few days. So I figured what I would do is take what I know, which is Swift and Apple platforms, um, and I guess the development tooling, and use that to build games, right? But what I was very cautious of, I've been thinking about doing this for a while, but I was really cautious of doing this because um, I wanted my games to be playable by a lot more people, even if it's just a very basic, crappy old game, um, that is just a learning exercise, really. And so I wanted to have a way of making that work, I guess, right? And my first thought with that was that potentially what I should do was sorry, I got distracted for a second there. I want to work with Swift, and I want to use, like, at least for now, Xcode. Um, I may at some point switch to NVim, but for now I'm going to use Xcode. But what I wanted to be able to do was to give this out, like I said, to a lot of people. And I'm not thinking too far ahead. I want to keep things relatively simple for now. But I did know that I want to be able to give it to my kids really, really easily, right? I have two young boys and they love gaming, and I would love to, I love for them to play some of the games that I make. And so to that end, I was looking into Swift for WebAssembly, And I have previously actually worked on some Swift for Windows stuff as well. And I have enough of an understanding of like architecturally speaking, in terms of like how to structure the code base to have this sort of platform separation that you would have in like a game engine. Um, and I know what you're going to say. Those of you who are a bit more experienced, why don't I just use Godot or Unity or something like that? And I have actually used those in the past. When I say that, I mean like over the last year or so, I've been very slowly dipping my feet a little bit in different waters. I don't have a problem with any of the game engines, if I'm being honest, but there's a level of knowledge that you don't get when you're using those tools, in terms of, for me at least, in terms of how the renderer really works. I'm not trying to become like a specialist in any one area, but I want exposure to as much of it as possible. And I just want to have, I think while on one side I do have a game idea that we can talk about in a future episode, and I absolutely want to like get into that. But there's also this other side of me that feels like I could end up building a game with a game engine, but I wouldn't really know more than I know today in terms of like how games work. And I think if you want to be, it's okay if you want to make a game. If you want to get a job in the game industry, I think that's a different thing, personally. Um, and so I feel like I want to delve deeper, right, and understand how these things come together more behind the scenes. But I also want to keep it simple. And I was watching a interview with John Romero, who's one of the original developers of Doom and Quake and Wolfenstein and many others. Um, and they were talking about sort of his history in the 80s, and I think even the late 70s, building lots and lots and lots of games. And I mean like many games per year. Um, and I think there's a lot of value in doing that, right? Like not just to like get in your 10,000 hours, so to speak, but also I think each even those old games, they still had all of the core principles of what makes a game, right? But they're also small enough in terms of scope that you can finish them, which is a big deal, right? Finishing work is very, very important. And so what I was thinking was, if I take Swift and I package it so that I can export to at least WebAssembly, that gives me a web distribution, right? I can go on like itch.io, for example, which is my probably my number one target right now. But at the same time, if I write it as a platform abstraction, it's really easy for me to then add macOS support, to add iPhone support or iPad support, I should say, which is where my kids can play, right? In fact, maybe even Apple TV. And so basically, I'll spoil the story, or give you a little bit of a spoiler. I've done macOS and web already for the core engine, if you want to call it an engine. I would call it a framework more than anything. And we'll go into that in a second. But yeah, I'm pretty excited. And so let's quickly go over the name as well. I called it Mood, which is, I guess, a homage to the game Doom, right? And there's this mantra or musing, I guess, that people often make when, like, I don't know if you know, but for example, there's a pregnancy test that can run Doom. Um, and it basically runs everywhere, right? And the reason for that is because they had this really great platform abstraction, but also, in addition to that, this was a game that was written long before GPUs were a thing. And so, anything that's targeted for the CPU is going to be easier to port. And so basically what they have is they have a platform layer, and they say, well, we need audio, right? We need a way to like load files from disk. We need access to the keyboard. In my case, I also wanted to add gamepad controller support and obviously touchscreen support when it comes to iPad. So you think about these platform abstractions and you create, you know, that code for each platform, but then you separate your game code, right? And you put this in its own in a way that you can compile that on any of those platforms, which is what I've done. And Swift is great for that. Um, Obviously, you can do this in C, C++, and probably well Rust. There's lots of other options out there. Some of them might even be um, have more established existing libraries and frameworks that you can lean into. But remember, again, my goal is to understand as much as possible. That also means I want to remove as much friction for the things I don't need to know. So I don't need to know C and C++. I need to know the systems, the architecture, the design, right? I need to know the fundamentals of game development, and that is not about the language, especially these days when you can use AI. I'm not using AI to solve all my problems. I'm not using AI to generate or to replace me creatively, but or to replace my choices, number one. But what I am using it for is to just jumpstart some of these bits. So what you're going to see is that as I'm developing, I will spend quite a lot of time in the discussion and planning phases so that I understand what we're trying to create. And I'm doing it in Swift so that I can very confidently review it and know when things are taking a wrong turn or if we could make an improvement, for some reason, and give great strong feedback to the AI. But I will use the AI to do a lot of coding because it's going to speed my time up, and I just don't have the time. So at the end of the day, I need to use every tool I can. Um, as a great example of that, I would let me share this. This entire project, if I bring up this is the Git history. You can see here, I started the project at 2 p.m. yesterday, and then I worked for until what? 2 o'clock in the morning, 2:30 here. So I worked for the entire afternoon basically, and into the night. And this was not constant. I had to stop and take care of the kids and stuff like that. So there were some breaks in between. But over a few hours, I got a lot of the foundational bits in place. And that would not have been as easy to do without AI. One in particular was this very last, these last three commits here. You can see introduces macOS support. Basically, because we had introduced enough of the platform web, and you can see here it's not it's not a lot of files. AI has a strong enough reference or understanding, and so I could say, I want to port this to the Mac now. It only had to implement that specific framework, right? Which is actually a target, sorry, inside the same package. And it organized a little bit differently, which is fine. There's no protocols or anything like that at the moment. It's very loosely, it's kind of a convention more than anything in terms of what types of features. We may do that at some point, but right now, like I said, I'm trying to keep things super simple. But this works. And I'll go over the targets like in detail in a second here, but here's the game core there. So the game core has sort of the real code that's completely cross-platform and is used for everything else. Now, the game itself is not really a game right now. If I just run this, so you can take a look. Oh, I think I had an update. Okay, so we've got this little guy. I can use WASD or even the arrow keys, and I can move around. We do support the space bar, but at the moment it doesn't jump, it just makes a sound effect. And obviously we have not just a sprite, but you can see this little walk animation as well. So we have animation, like sprite animation as well. Now this is obviously not going to be a 3D game at any time. My goal is to think back towards the 80s, pick a game, and essentially build that, like almost literally that, but as quickly as possible, and to not use an engine, to use this to basically do everything in Swift. And it's not because I'm picking Swift for some strong technical reason. It's really, like I said, just a personal comfort. I know Swift, I know the tooling, I know the platform that I'm building on really well, and it's very easy then for me to like put that aside and focus on the things I don't know. If I added C, C++, or Rust or something like that, I'd have to spend a lot more time understanding just the environment that I'm in before I can do meaningful work. And that's just, I don't have the time for it, but I honestly don't think it's a good use of my time either. So you can see that that just works, right? Now, if I actually come to the command line here, and we, oh, sorry, that's not correct. I don't know why I tried to run that one. Oh, swiftly install 6.3.2. So sorry about that. I actually started this project on a different Mac, and so I don't have Swiftly installed right now. Or sorry, I have Swiftly installed, but not the specific Swift version. We need to use this one. So anyway, we can set this up and put us on 6.3.2, and then we can run the build script. And what that basically does, if I open this up over here, it's relatively simple, but basically it's going to I support either obviously debug or release configurations, and then essentially it's not really showing the. I mean, it is in here, but I'm not seeing it. Where are we? Okay, I'm not. Oh, I think it's just the way that I've written it out. Basically, it will build the project, but targeting Swift WebAssembly. So it will basically the compiler at that point is cross compiling, so it knows this is not macOS or iOS, whatever. And then I run another script, this one here, deploy wasm, which basically packages it up for itch.io. And this is working as well. Not something that I'm directly using at the moment, during development, of course. And then it runs a quick Python server to launch the actual game in the browser locally so that I can do testing, which is really, really useful. Okay, so that's going to take a few minutes, interestingly. Okay, yeah. Let's go over the package. So, like I said, I called the game, or the framework, I guess, Mood. Doom backwards. The reason for the platforms macOS thing here is just because when you want to, so I think that this package here, I haven't gone to the package itself to check, but I got an error about this. Basically, this package, even though I think it requires a minimum of macOS, I don't know if that's a compiler constraint, it might be, or if it's just JavaScript kit has something in like some macOS tooling it uses, which it knows is available on macOS 13. But anyway, so you have to have that minimum in order to have this particular package. But this is basically the from SwiftWasm, so it's an official-ish package that essentially provides interop with JavaScript and the DOM, so that you can actually use WebAssembly. Sorry, you're compiling from Swift to WebAssembly, but you can interact with the web applications. And this is necessary, obviously, for like hooking up keyboard events and event handlers, and even like rendering into a canvas and getting a WebGL to context and things like that. So it's really cool. But this takes care of that interaction layer, like basically an SDK, and makes it a lot easier to work with rather than raw strings, I guess. Okay, and then we've got my targets. So game core is what it just says. It's basically the core game code. There's no specific name or anything like that for now, but that contains all of this, what you see here on the left. This contains all of the game logic, which is cross-platform. This must compile at all times, no matter which platform you're compiling on, right? Then you've got two targets, one for the Mac, one for web, right? I might need to rename that. But basically, you can see here we use conditional product, so we can attach the dependency for JavaScript kit when we're targeting WebAssembly, right? If we're not, we obviously don't want that. Without this condition here, every time we try and compile, like say on macOS, this would also try to compile this dependency, which it can't. So we need that, and we do sort of a similar thing down here, I believe. Oh no, we don't actually. Oh yeah, we do for the executable target. So the executable target is this mood. It's the main package. If you look, is one file, and it's really, really simple. It just needs to run the correct, call the correct static run method that I've created. And there's a little bit of a interesting thing we had to do for macOS specifically, but basically this is this is where the platform switch code goes. This way, each of these frameworks only has to have the code for that platform, right? I don't need to try and wrap, because otherwise, without doing it this way, each of the um, where are we? Like platform web, for example, here, this whole file would have to already be, oops, sorry, wrapped in like, um, WebAssembly or whatever. Like I'd have to I'd have to check it constantly, um, in every single file, and it would just get messy. So I decided to abstract it this way, and that way the Swift code stays nice, simple, clean, and just platform independent, um, from a writing the code perspective. It obviously is dependent on that platform. And then for the macOS app, we have to copy in the resources from our assets folder. So we have a game folder here, which is outside of our sources. This is not in the source code. And this has like audio files and sprites right now. And the reason I did it that way, we do want to copy them in, like as I'm doing here. But in the case of WebAssembly, um, the way that gets sort of copied out is different, and even again it's different for itch.io, for example. So you essentially have to like take your assets and package them slightly differently depending on your distribution, and it's not specific to the platform necessarily either. So just to like make that a little bit easier to work with, I store them in a top level folder, and then I copy them in here just for macOS. For the, like I said, for the WebAssembly, it happens in the script, so we don't need to do it in the Swift. That would be a nice thing actually to consolidate and like have less reliance on like a shell script later on. But for now, this is fine. And then we've got the executable target, like I said. I think I already covered that. So yeah, that's basically it. It's really, like I said, very, very, very simple. I'm trying to keep it as simple as possible, but get the most out of the simplicity. Right, I think that's a reasonable stopping point there. Let me see where this is at. Okay, that's good. And we can switch this now. Okay, and then if I run this, this should now work. And so we should get, this actually, this runs pretty quickly usually. It's looking good so far. This will basically give us a locally hosted website that we can open up. By the way, I don't know if you can hear the fan, but it's very hot at the moment, so I apologize. But I really need it. Oh, I did not install the, that's a good point. Swift 6.3.2 WebAssembly. There is, I think it was I remember, I actually forgot about it until right now, but I had to do, um, this. This will install the WebAssembly SDK. You can see that here. And so this is necessary just to have that installed before we can, and then I don't know if I had to run that one again, but let's just do that. This way it'll find it when it looks for the SDK. Otherwise it will use the host system, which in this case would be macOS. It's not what we want. We don't want the same version that Xcode is using, basically. This is a release, by the way. It's not a nightly or anything like that. It is a release version of Swift, which is also very cool because it means it's more stable. I guess because I never compiled on this machine before, so I mean the project's a little bit bigger than it was when I started it yesterday. It's not huge, mind you. Okay, that worked. It's great. So there we go. And then if I run this here, you see that we have the exact same game and sound effects, sprite, animation, everything, right? It's very, very cool. So basically we have, like I said, we have a relatively simple project if you really think about it. I mean, a lot of this stuff is like the setup script, the mood zip and dist here are both outputs, like from the distribution scripts and stuff, so they're not even there. Agents file is what I'm using obviously for the agents. This is describing what this project is. and the rules around development and intention for like going into other platforms, stuff like that. It's a little bit outdated, actually. I can see that now. But mostly like what is important is this stuff about like how to set up the project and stuff like that. Obviously, I just did it manually, but yeah, I actually did forget that that was there. But anyway, yeah. So that's working there. And then if we go to where is it? Roadmap. So this is the main way. Actually, I might open this one here because I think it will be no, not that. What the? I actually don't know why that opened. Did I? What did I click? Open roadmap. Hmm. That's the right file, but it should open in line here. It did earlier. Okay, let me. I don't know why my note's opening, let alone crashing. But if I come here to roadmap, and let's just use Z. This is a nice fast editor. We can just move this over here. Oops. Okay, so I broke this down into I guess I was going to say milestone. Well, they are milestones, but into phases, I guess, right? I wanted to just have some kind of, I guess, very high level understanding as to like how to go from point A to point B. This was my design, but there were things that we added, like this native debug platform, which was basically macOS support. That was introduced after, like halfway through, because basically I finished the first four or five, I guess, milestones, and then I realized it was really difficult to debug when things were not working right, and which hadn't happened yet, but I was anticipating it, and I thought, okay, I think the best idea now would be to introduce macOS support earlier than I was going to, because then I can run it with Xcode and debug and have the console. I can check CPU and memory usage and all those types of things. So it was going to just make development of the actual game a lot easier. Like I said, use the platform that I know and the tools that I know. So it did adjust, but mostly this is the original set of milestones that I outlined. And so the runtime was basically it's just underneath this. Let me click on this. So the runtime was to set up the compile, like get it to compile to WebAssembly. Can I do that first of all? Then I wanted to test that I can actually take that and run it in the browser, which it worked, which was great. And then we wrote like a basic game loop, which was just using a console log that just logged the time at the delta for every frame at 1/60th of a second. So 60 frames a second. Then the second milestone, as you can see here, was to get something to render. So I wanted to make sure that I understood how to get a WebGL to context. I wanted to be able to clear the screen, draw a rectangle, move the rectangle, which at this point we didn't have input. So that was just it, like a rectangle bouncing left or right across the screen. And then I decided to do a quick deploy to itch.io because this required, like I said, the distribution packaging had to be a very specific way. If I actually show you that over here, you can see that this structure, which happens to match for the assets, happens to match this. That only matches just because we knew what the original target from the beginning was going to be itch.io. So me and the AI worked together to like align that early. Knowing that it would be pretty portable. So that was why. But other than that, obviously you have to have an index file, which is like really simple. This actually gets generated by the script as well. And then there's a JSON file, which is generated by the JavaScript kit framework. Or it might be, I think I think it is provided by them, but I think you have to download it for itch.io because you can't have like a CDN reference basically. And then we get the WebAssembly executable, which we've from Swift that we generated. And that's basically it. It's pretty simple. And so when that web page loads, it then runs the game straight away on itch.io. And I don't have the same version of the game right now, but I can show you because I did actually make it it's on Odd Pixel, so you can actually come to this page if you wanted to as well. We'll be adding stuff there over time. So there you go. So this is a very, has the same movement, just doesn't have the sprite, the animation, or the sound, because I haven't uploaded a new build, but it is the same game otherwise, as you can see. And also you probably sell the movements different. I added like acceleration, deceleration, things like that to play around with the game code a bit when I got bored. And then obviously, yeah, the web version does not have that yet. So that's there. Okay. Milestone 2, which I guess is the third. I don't know why I did 0 indexing here, but input. Obviously, I now wanted to be able to move that little box, right? As a player. So I added keyboard support and I added very basic touch support. You touch the left side of the screen, you go left, touch the right side, you go right. It's only a horizontal movement for now, but it works and it's good. This just allowed me to quickly throw it on an iPad and make sure that the same from the website, not an iOS build, but a WebAssembly build running on an iPad in Safari, and it does, it works. It's really cool. And then I also added controller support. I don't have my controller here right now, but I have a third-party controller that I just quickly connected to my Mac. That worked when I'm in the browser, and it also works when I run it locally as a Mac app, which is pretty cool. Then obviously, once you've got input and some kind of rendering, you need assets, right? You want to see something real on the screen beyond just rectangles. So we decided to upgrade, add support for an asset, for loading assets, both images as PNGs for now and audio, and then also making sure that we package them up correctly, as I said, for the distribution. That converted us from a rectangle to the little character you see. And then we focused on sprites specifically. So sprites require, it's great if you can load an asset, right? That's like the file, that's kind of the platform layer stuff. There's actually some more stuff at this point that's in the platform layer as well. But basically, you then want to you want to be able to generate textured quads. Okay, so obviously, like we're running on a GPU, everything's basically a triangle, and you have vertices to make up your both your triangles and your quads. But then you want to render like a texture on that quad, right? You also want to be able to load sprites from a sheet, because you may have, lots of different sprites on one sheet for like, to load it faster and compress it on disk, all sorts of reasons later on. But also, more importantly, for animation, I wanted to support like an idle or a walk cycle and things like that, and which you see in the game already there, right? His little walk cycle. Um, I did not create that sprite, by the way. That's from itch.io as well. It's a free download. So I wanted to have animation support for sprites. So that was the milestone 4, which went really, really well. I did get quite a bit, I was getting late in the night, so I got quite a bit of support from AI with to just speed up some of this, especially the texture quad stuff. It's like I can sort of show you, but basically, if we go to like say the web version, because it's slightly smaller, not much smaller, there's all of this pipeline stuff that you have to just do, like I do understand the conceptually how you build this up, because it's actually kind of similar to MetalKit, and I have done some of that manually in MetalKit before. But essentially, you want to generate your texture. You then need to bind it, to, in this case, your GL context. You text image 2D. So I guess this is like the actual mapping of the image. And yeah, I mean, look, I can't explain every line here because I'd need to sort of really think about it, and it would be wasteful for this conversation. But what I'm trying to say is that it's just a bunch of boilerplate, right? For like any given sprite texture, you just need to write this code. And to me, that seemed like a wasteful, it's not a thing that I need to like learn deeply right now, right? This is a means to an end. So I used AI to generate that. And then, yeah, like this kind of stuff that I might not have even known. I mean, I did choose like between linear and nearest, because I knew that was like interpolation modes. I've seen them in game engines before. So I knew I was going to need that, and I knew why. But how to write the code to do that, I didn't know. So I, yeah, used AI for that. So in my opinion, this is where AI shines the most. And I think it can assist development to do things that would have taken a lot longer, and you have to go and find all the really good, the best resources you can to do that stuff, or a person you can talk to. um, it's kind of tricky. So I really appreciate AI when it comes to this kind of thing. What else we got? Milestone 4.5. Oh, so like I said, then wanted to introduce macOS support, and we did it all. But basically, like I said, predominantly so that I can improve the development and the debugging in particular, workflow as we move forwards, because it's going to become more and more important. This was really cool though, that I was able to just tell AI in one prompt to do this, and because there was enough like of the rest of the project that it knew exactly what I meant, and it just did it perfectly. Um, Organized it a bit differently, maybe in some ways better, I would say. Um, but that's fine. It doesn't really matter at this point. So yeah, organize those two. I ran the app and it just worked. And then it created itself a little checklist of things that it had already done, which was kind of funny. But it's just to like posterity, like just to like make sure that we've captured the work that's been done, I guess. And that brings us to now, right? So the next steps, which I don't know if we'll get into today, but basically we've got tile map creations. I want to add support for collision detection. I'm just thinking bounding box for now. Keep things simple, and that would suffice for like, I hit a wall or I hit the edge of the screen and things like that. So I think that would be good. And then I would like to add very, very basic spawning support, so we can spawn the character or enemies or whatever at specific points. Right now, the character just always spawns in the center. And also because you may die and we need to like respawn you again, things like that. So just some very basic thing. And then when that's all together, I think it would be great to like add at least some kind of basic 2D camera as well. And that would allow us to like move around the screen and make the world feel a little bit bigger when we want that. If you think about it, this one here, this world milestone is a big one. Not just a big amount of work, because actually it's not the tile map thing. I'm the least certain about. Everything else I've kind of done before, so I know it's not like a huge amount of work, and we can definitely use AI again to like speed up some of these. But the camera, spawning me in a new location, all these things are like really, really simple because they're just like some kind of state update, right? Tile maps is slightly more complicated, I think, but I could be wrong. So that's where we're at. The last couple of milestones, just so you know where we're headed. Obviously, a playable game. What I meant by that was not like a game that you ship and everyone's like, oh my God, I want to play that game. But at least some kind of, using everything I've done so far to generate something that you can jump, you can walk around, maybe there's something you can collect, maybe an enemy that can hurt you. It's not a small task, but it's a nice isolated piece of work, and it's at that point should be entirely focused in game core, right? Shouldn't touch any other platforms. And so it'll be smaller touch in general. And then when that's all done and we have it published on itch.io, and now because we've got macOS support, that proves the purpose of it, right? It gives me relatively quickly it's not, I wouldn't necessarily, I struggle a little bit with the meaning of game engine. I feel like a game engine has a lot of systems, and this doesn't really have systems, right? It has a bunch of small, very basic required functionality. So for me, it's still very much just a framework or a library. And I was heavily inspired by those early games, including Doom, and I feel like nobody probably looked back and said Doom at the time, at this stage of the project, would go back and call that a game engine. Maybe I'm wrong. I mean, I don't know. I don't know where the definition comes into that. But for me anyway, this is awesome. The fact that I can write all of this code, well, the game code once, but all this other code I write once per platform, and then I reuse it all over the place. Maybe it is an engine. Is pretty cool. And what I also am excited about with this as well, not that I think that this is going to be like used by anyone else, by the way, but what I am excited about is that knowing that I could create like some kind of game that is certainly any general 2D game, I would imagine. Run it in the web, run it on a Mac, run it on an Apple TV, run it on Windows. I've done Swift for Windows, and that's actually definitely possible here. Um, and I think even if I can get it on Windows, I wonder how much of a leap it is to get to Steam so that I could run it on like my little PC handheld, my Xbox Ally X. Um, I'm not going to consoles anytime, I'm sure, but if I could at least get it on Steam as well as itch.io, I think that would be really, really promising. But it's really not like a goal, you know what I mean? Like my goal right now is to create a game and learn as much about it as possible, like the entire process and the parts that make up a game, and the journey of being a game developer, I guess, an indie game dev at this point. Um, and I don't know where that's going to go. Like I said, I do have an idea for a game. I think everybody does, so that's not, unique. Um, but yeah, I have a couple ideas actually, and I will go into them in the future because it would be nice to discuss them. But maybe I'd like to wait till there's at least some kind of audience, because otherwise I feel like I'm just kind of talking to myself. Um, okay, and the last milestone I added here was that when I've got all of that to some really good state, I feel like I've got a couple of platforms, and I've got the major, like the minimal, I should say, not major, but the minimal pieces in place that allow me to write a game and just distribute it on some platform. I would like to do a tooling review because, like I said, right now there's the build script, which really just, excuse me, does a Swift WebAssembly compile build, right? And in the yeah, and uh, and redistributes for WASM, and also runs a Python server so that I can do local testing for the web version. Deploy WASM just does the HTML, like writes the index HTML, and then basically runs the same thing, sort of, but packages it up in such a way that it can be distributed to itch.io specifically, right? Um, and that's basically it. Everything else at the moment is a Swift package based thing, right? So I wonder if I could potentially write a Swift package plugin that would do the bundling distribution part. Um, and I don't think I can. To be honest, I don't know if it's actually possible for me to do that in Xcode, because Xcode's going to use its version of Swift, and that's where that problem really begins. And because, at least for the moment, I don't really want to create like an entire Xcode project, I don't have things like build phases, right? Um, and the main reason I don't want to do that is so that I can like open this same project as a Swift package on Windows, for example, in like VS Code or NVim, and I can uh, do the Windows build later on in the same code base, right? So I don't want to use an Xcode project. Um, so my idea for this like Swift tooling review is to actually consider building a little Mac app, um, which maybe, let's say a Mac app that has that points to the Swift WebAssembly build when we're dealing, like basically something like a very, very simplified build tool instead of Xcode, but it allows me to do these basic things and to run the hosted site live. So essentially I could almost have like a little app that is the game, but also the distribution build and all that kind of stuff in just a really simple little UI. So I don't need to run those commands manually, right? I probably would just have it run those commands, which is why I'm thinking a Mac app. But yeah, I don't know. So something potentially just to like bring more to Swift, and or at least, the Mac, so that I can simplify the process. Right now it's not that painful, but I just imagine that like over time it might get painful, especially when I need to do more complicated things with assets to like package them up and stuff like that. Um yeah, like I said, I'm not 100%. I think I just said a lot. And again, we will revisit tooling later on. And then identify which workflows. Yeah, okay. So I think we've covered it. So let's close out this here. Okay, so one more thing I just want to point out, that in terms of my workflow here, we all have our own kind of workflow at this point, particularly around AI. So I'm using Codex. I'm not really a fan of Claude. Used to be, but I switched to Codex maybe in January or February. I think it's February. And for me, it has been not just more reliable and I get everything I need out of it, but also it doesn't mess around as much. And it doesn't like get gung-ho and just go and like do stuff until I really want it to. I feel like it's better at following instructions. That's my personal preference anyway. So yeah, we're all in with Codex. I'm using mostly 5.5 high at the moment. And I give it full access because I just can't be bothered with prompts, and I control things quite well. I won't go into the skills I'm using just yet, but I do have a bunch of its skills installed for very specific purposes, that I actually think that is going to be a really useful thing to talk about sometimes. But let's cover that when we get there. And yeah, because I wrote the roadmap and the agents file points to the roadmap, I can just start a brand new chat like I did at the beginning of this session, and just said what's next on the agenda. And yeah, I told you it's going to be the world building, not world building, but the world milestone, which we know. So that's how that's going to go. Before we continue, I just want to check. Okay, looks like stream-wise is still going, so that's good. I was genuinely worried that I will not get this right. I mean, I still don't know. I'll probably watch it back on YouTube later and see a whole heap of issues. And that's how we learn, right? Okay, so I think it would be cool to actually do some coding. I know that was a really long intro, and I won't do that every single video. I'll need to find a way to like summarize that every time. Or maybe not every time. But until there's an audience, feels necessary. So, okay, add tile map in game core, render visible tiles as sprites or Rex, move player balance from screen size clamp to world tile collision. Yes, add spawn point. So I think the ordering of this makes sense. I'm just double checking because we changed things. I think what would be useful, actually, I'm just realizing now, but might be useful for me to like go through a little bit of code just in terms so you understand like how the game itself executes. Okay, so if we go to game, a game is just a struct, right? This is the starting point, though, essentially for the entire project. And obviously, where's the initializer here? So you can initialize with a width and a height. At the moment, I've just set it to basically be 720p. You can set the interpolation mode, which I've defaulted to nearest because I'm just using pixel art for now. And then you can give it a preferred FPS, which will change your frame rate. Again, defaulted to 60. Now, we do two things straight away, right? And at the moment in the initializer, this may change later on. The first thing is we go through the players, which there's only one right now, but you go through the players and we place them within the world size. And this is basically what puts the character in the center of the screen, so that the first time it runs, that's your starting point, right? At the moment, by the way, players are the only type of sprites I have. So this will later change, like we'll have a separate array for players, a separate array for enemies, think something like that. I don't want to build like a complicated entity component system anytime soon, or I don't even know if I ever do, if I'm being honest. So I'm going to go with this. I'm going to keep things really simple and just each type in its own array. And I've seen this used by like some really like game developers I really trust and respect, and I think it's a very viable approach. I think even in larger games, but certainly in like the type of games that I'm planning on making from the 80s and 90s, this is not going to be a problem on any platform. Modern computing is just Great. And then the second thing we need to do is rebuild the sprite buffer. Okay, so basically what this does is, and it actually doesn't, does it do, oh yeah, this one, sorry, it's down here. So what this does is that we need to go through each of our players, right? Again, we only have one currently, and we read their sprite and load that into a buffer. Okay, and so this is just so that we have cached it. We only do this once per type of thing we have, right? This gets called, actually, it's not true. It gets called again, I think, in the update. Yeah, so we do it again. I'd actually this so I've I think this is a little bit of a mistake from the AI, because I don't think I wrote it in the update originally. In fact, we can just quickly do a test here. If I take that out, I'm pretty sure this all just works. Oh, okay, it doesn't. But the reason, okay, now I know why. Just as soon as I realized the animation's not there, I understood. So I don't know if this is the right way to do it. I came up with this because I was just really not sure, and it was based on the idea that AI gave me. I keep saying it, but that Codex gave me for like draining sounds every frame, and I was like questioning what the hell this is about. So essentially, the way that it typically works is that in a single frame, you may try to play multiple sounds, right? But you obviously don't want to keep them around, especially in like on a mobile device or web or something like that, where your memory constraints are low. But just in general, you don't want to uh, hold on to assets and memory that you don't need right now, right? And so the way that you and so you want to release things, but you also, with games, you don't want to alloc and dealloc often, right? Because then you're going to just kill performance as well. So you need kind of a mixture of strategies where you want to once load up all the things you need and then keep them around. And in many cases, especially for small games, you keep them in memory forever, like for the entire life cycle of the game. And you're usually using such a low amount of memory these days that it's really, for those types of games, that it's just not an issue. But if you're doing that, you don't know which sounds are like active or which sprites you need to see right now, like in the middle of an animation, which frame should I be seeing for that character at that given moment. So there's this idea that basically you build up a buffer and then the platform layer reads that and does the rendering for those particular sprites or audio player for like sounds, and then it needs to drain them, right? It needs to like clear out that array. So that's basically what you're seeing here. They're written slightly differently, but they're essentially doing the same thing. And so every time we get an update method, right, every single frame, in this case 60 times per second, we generate a context, which I'll cover in a second. We then loop over all of the players and call their update method so they can update themselves. Then we append all of the sounds that were added from the context. I'll go over that in a second. And then we rebuild the sprite buffer. So these two lines here are at the end of the frame so that when the renderer kicks in or the audio player kicks in, they know exactly what to show and play. And then we clear them out, right? So let's cover the context real quick. So this is again like just me knowing Swift and making a decision on the architecture here, but essentially every frame there's types of information that you need to know, which in game engines, because of the way that they're written, because they're often class based and like so therefore they're very I was gonna say hierarchical. That's the wrong word I'm looking for right now. What am I looking for? Um, Object oriented. So so you have classes and subclasses and subclasses, and generally you get like say a character or a game object of some sort, and you subclass it, and that becomes your player, for example, right? So then you inherit a bunch of functionality, and that's kind of not how we would typically think in Swift, and so I wanted to like keep things as lightweight as possible, especially where I can use structs because I know how much faster that's going to be. And so I added the concept of an input on a context, right? So every frame, this will be the current inputs. If you're holding a key down or multiple keys, this is going to tell you what those keys are, as well as any other input. So this is all, this is like uses a combine approach, so not combine as in Swift combine, whatever, but essentially you've got like sort of, you could be holding like either left or right. So we represent that with -1, 0 if it's you basically off. or one. You can also, for like analog control sticks on a game controller, this will be 0.5 or 0.2 or whatever. It's not going to be an exact number. Same for vertical, obviously. And then I've just introduced the concept of like a jump. I wanted sort of, for now, to keep it really simple. I don't want to know about every key on a keyboard and every type of device that has different buttons. I just wanted to have like a semantic feeling of like, not feeling, sorry, a semantic understanding of the type of input, right? But then I introduced this combined. So here you can see that this then combines these same three with like together. So essentially, like if a different input is providing, where this happens actually is like, for example, I'm pressing left and up at the same time, and now you want to move diagonally. I need to know about both, right? I need to know what is the horizontal and the vertical value at the same time. So this is a very simple approach to doing that, but it works for what I'm doing for now. This may need to evolve later on to something more sophisticated. You also want to know how big your world is, right? Because if I want to know where the edges are for when I'm placing tile maps, or if I want to know, right now we use it to center the player, right? So I need to know how big the world is so I can center the player, things like that. And then obviously you need some kind of functionality. So this is the case where you want to call play sound. I want to play a sound. By the way, with sound is like, obviously you want it to be like just something simple like dot jump, right? So you essentially, again, I used Swift's sort of, oops, that was the WAV file. Nope, wrong one. Where is that? Was I here? Oh yeah, here we go. So sorry, here. So a sound is a very, very simple thing that just represents an ID. And if you go to the ID, is also statically declared, it essentially just needs to have something that we can identify it with, right? And so this here just allows me to like wrap this up into like something nice and tidy. We can go over later, like if anyone's interested, the specifics about how that works. But for each like sound, I will say this: sound ID, sound asset. And if you go to, or if we look up sprite, you'll see a similar kind of pattern. No, okay, I've renamed them, but they are kind of similar. You've got sprite and sprite asset, and then you've got sound and sound asset, right? The only reason that sound ID is obviously very different to texture ID is because you want to know the texture that is going to represent your sprite, right? The sprite is the thing, it's like a thing on the screen, like a player or an object or an enemy or whatever. The texture is the actual drawing, and you can end up using this for like things that are not necessarily a sprite, right, or something else. So it made sense to like use a different representation for that. Anyway, so the context wraps that up, and then in the loop, I'm probably not explaining this very well. This loop here is the game loop. So this is very simple because it's just like the minimum thing that the platform would know. So the platform calls this method every frame. All right, the loop itself happens in the platform. I did it that way because WebAssembly, you use like a JavaScript like callback basically to get the animation runtime, sorry, a callback for like every loop. And on macOS, for example, and iOS as well, anything with MetalKit, basically, I know that you essentially get a view, like MetalKit view, and then you get a callback there. So you're not in control of like constructing the loop. Some platforms, like I think on Linux and I think also Windows from memory, you are responsible for like writing the loop, um, I believe, and or at least in some cases. And if you wanted to do that, let's say you wanted to create like a 2D CPU renderer that is on a for all platforms as a fallback, let's say, you could do that, and that would then allow you to write your own, or in that case, you can write your own loop, and you just call the update whenever that's happening. So the game doesn't care about how the loop happens; it just needs to know what is the current delta, right? And what inputs have been put down. So it uses that to generate the context. Like I said, we do all this stuff. And then if we go into like a player update method, so if you go to a player, you can see it's just a really simple type. Okay. The only thing that's kind of, again, I haven't formalized this with like protocols, but if I did, I think this would be perhaps the only requirement. If you have some kind of thing, right? Let's say a player, it needs to be instantiated with it needs to be backed by an entity, essentially. right? And the reason that that is the case is because you, first of all, like the entity is the unified representation. In fact, if I show you this, it's a size. So like how big is this thing, which is going to be used later for like collision detection, stuff like that. Its position, right? Where in the screen its center is, and its current velocity, which is how we can make it move, right? Because the velocity is a multiplier, essentially like a multiplication of the position, current position. Um, so not a multiplication, you add them together. So essentially you want to make sure that you always have an entity. All right, this is the thing that I guess what I'm trying to say is that the platform and or the game need something that they all understand, and that's what an entity is. But without doing like subclassing, right? Oh, sorry, and sometimes a mutation like moving the object, right? So the transform essentially of this object. Without subclassing, I don't have a way of having like dedicated types, let's say a player or a different type of enemy or a wall or something like that. I don't have a way of representing those things with their own set of like properties and behaviors. Okay, so that's why I did it this way. And that's also why you might recall in game, I said to you that there'll be like an array of players and an array of enemies. I need to know what they are, but only the game. This is all in game core, right? So it's important that it stays here, and it could be formalized later on. But I'm trying to keep things simple. I'm trying to do things like in the old school way, not trying to build a really complicated engine. So just keep that in mind. It's kind of an important detail, I guess. Um, and so, like I said, the engine will later on say, "Hey, these are the sprites I need to draw." Gets added to the sprite buffer. So the sprite also has to have something like that. This is why we have the ID as a separate thing, and a sprite, which is the unified thing. So this is the unified understanding. It's public, right? This is the unified understanding for the platform. The platform from this can say, okay, he wants this texture ID, which it would have pre-cached, right? During when the game loaded. So it can take that. It takes the source rect, so it knows what portion. So if it was a sprite sheet, for example, it knows it wants that frame in the animation, for example. It can position the sprite because that might not always the position and size often in the beginning at least they're going to match, right? You're going to have like an entity and a texture and they're put on top of each other, but you can move them or resize them. And a really obvious example where this happens often is where, for example, your image might show like me holding a sword, right? But you don't want the rectangle to end at the end of the pointy sword, right? Because my body's over here. And so you would intentionally move the rect for the player to cover their body precisely so that collision detection is a little bit more natural. So there's basically you need to have the position and size on both of those. So again, you might already know this if you developed games before. I'm explaining this as if you never have, just because I don't know. I think I'm just sharing what I've been learning. I found this kind of interesting, to be honest. I mean, I've seen it in game engines, but until I was like implementing it, I don't think I fully understood how this actually works. Like I said, the game engine does remove those details. So that's the sprite. I then gave myself a place function, which is only called during the initialization at the moment, but this will be reused later when we do like the teleport kind of idea, which is just so that I can move a player from one position to another instantly. What else we got? Okay, so then we've got the actual update method. Like I said, we give you a delta and then we pass you in a context. It needs to be in out because there are some methods like play sound that are actually mutating. From this, we can read the input, we can read the world size, and then we can use that along with our local, sort of state to do something meaningful, right? Which is really, really great. And so that all just works. And then we've got, so for example, here I introduced this other concept of a timeline. Let me just go over this quickly and then I'll go into timeline because I think that was really cool and relatively simple implementation. I was kind of surprised how it came together. Basically, what this is doing, most of this, the velocity part is pretty simple, right? Just take the input, decide which way we're moving. And then the rest of this, like, pretty much all of that is like, where do you want to go, and then where's the world? And it's basically so that when you hit the edge of the world, you stop. That's all this is really doing. It's a really complicated way of doing it. I'm actually going to extract that out because it feels like one of those things that you wouldn't want to have to write always in every single character, player, whatever. Um, and then if I just show you this real quick, I have like helpers for like calculating the current velocity. This is because I wanted for now at least to have like the option of decelerating and then also accelerating. And in the case where you are, let's say you're going left and then you suddenly go right, we want to sort of have a bit of inertia. So you want to decelerate quickly before you shift direction. So we need to know when you're reversing. So again, there's a little helper there for that. And then the actual methods for acceleration and deceleration. Again, like, don't know if they're like the best way to do it. I think those actually I used AI. I know how to write that mostly, but I think I might have actually just asked Codex to do it. And down here is just the definition of the walk. So if I show you the actual walk, nope, it's called player. I should rename that. There we go. So that's the walk frames. So there's 4 frames, right? Just boom, 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 boom. And obviously that I know because I created them, they don't have any gaps. There's no bordering, and they are 48 by 48 pixels in dimension. And so I gave myself this concept of a sprite animation where I can pass the texture ID. So this tells me like which, sprite file to go and load. And then I can outline which frames of the animation I'm going to have. So you can see here they're all the same width and height, but they get offset along the X value because it's a column-based sprite sheet. And then I give it a frame duration for each frame. So this will play for 0.12 seconds per frame. Now this seems a little bit limited, but I looked into how this is done. Like if you wanted to have a different duration per frame, it gets really, really gnarly in terms of performance. I know in my games and the way I'm going to build this is going to be really simple. I just don't think that it's going to even be a performance problem. But I wanted to think scalably, like at least on some level. And for me, that just did not seem like, until I understand it better, it didn't seem like the kind of mistake I want to make early on. I'm pretty sure it's ON as opposed to now where it's O1. So the complexity is much, much, much simpler now. I did add, however, like to just be creative with this. Again, maybe this is like super common in the game industry, but I had to come up with it on my own. I was trying to think about like how I could take something that's very simply defined and make it more dynamic. So one way obviously is like adding in the movement itself, adding acceleration and deceleration. I think that helps a lot. Later flipping and stuff like that will also help. The other thing I thought would be really cool though, I don't think I implemented it yet. Oh, I did. Well, okay, one thing I did implement, which is the concept of speed. So you can actually change the speed of the timeline so that each of those frames, that 0.12 gets multiplied by this. So essentially you can speed it up or slow it down. That does do the whole thing. But I actually realized later on that what would be cool here is that I could introduce like an easing curve. And so then I could have what do you call that? Not translated value. I'm blanking on the interpolated value. So you could basically like have interpolation function, which depending on like what part of the animation you're in, maybe it starts sort of slow, like you start with a slow speed and you get faster. So you could sort of simulate. You wouldn't want it necessarily for this, like for a walking animation, but a good example would be like where you have frames of a sword swinging, and you want this to feel like a sort of slow and then and then fast right at the end as the sword comes down, right? And without complicating the animation timeline stuff, this would give me that, right? I could actually achieve that, I think, with this kind of approach. I don't know how realistic and good that's going to be, but something worth exploring anyway. And it would keep performance and all the rest of it very, very fast because it's just a bit of math. So it should be pretty good. Yeah, I'm excited about that. So let me show you the actual timeline real quick. This is very, very simple. So a sprite animation, as I said, is similar to a sprite itself. Okay, it has a texture ID. The main difference is you have a duration, whether or not it can loop. I don't know why I've got that stored twice. I think that might be. I think that might be a dupe that I forgot to delete. I'll check that later. And then you have frames, right? The actual where in that texture ID are the frames for this animation. In order to play that, you need like some kind of player. So I decided to, because I have like this concept generally in a game, you're going to have a player. I didn't want to use that term, so I went with the term timeline. And basically, a timeline, you attach the animation to this, and then you can, like I said, override the speed, and then you get the elapsed time. So this tells you, essentially, we use this. You can see down here the maths of this. Essentially, it just gets updated every delta, and then when we want to know what frame you currently want, right? We ask the animation for its frames at that elapsed time. And this here, you can see here, it basically is a bit of division, right? It's a mod, I should say, and division, where we're going to work out which frame lands inside of that duration within the whole thing. Maybe that's why I have that, actually. It might be, but that's on the animation. Sorry, I'm just trying to understand this duration here. Yeah, so this duration is the total duration. That's the frame duration. Okay. So uh, it's fine. I'll leave it for now, but I probably should rename that to total duration. Anyway, you hopefully understand the idea. So the sprite animation I think is pretty cool, or came together pretty nicely. Again, I just like the simplicity of it, and it works. So I don't know if there's like a better way to do it or a cheaper way to do it or whatever. These things I'll work out over time if they become a problem. But for now, they're fine. Under the support folder, they're not exactly support. This was me just trying to sort of understand early on what parts, like, and it's not actually this one folder. It's kind of all three, and maybe even the game. I started to realize that game core is kind of like right now, especially, it's predominantly the glue between the platform layer and the game. And so there's actually kind of a missing framework here, right? Or a missing target. The actual game itself probably belongs in its own target, like its own package or whatever, and its own library, let's say. And then you'd want the game core, or I think it would actually probably be essentially mood, right? You want mood to become the Oh no, sorry. Odd. I think I was going to call this Pixel Engine or something like that for the Odd Pixel channel. But basically, yeah, it's like the Pixel Engine bit would be the code that is consistent across all of like everything, basically. So like knowing that entities exist, knowing that a game exists, things like that, and any rules around like how you, for example, you create a player, and therefore it has to be backed by an entity. Um, I think I would want to use like a Swift data. This might be out of scope for some of you, but the using a macro, I think I could solve the entity backing issue automatically via a macro, which, if you know what I'm talking about, it's actually really, really cool. And it would make defining, like if you want to define, for example, player, or let's say an enemy, you would just do this and you're done. Right, you wouldn't have to do like the conformances. You wouldn't have to back it by if you were to create a function here, whoops, and do this, you would see like autocomplete and everything, and you'd have an entity, and that would be done by this macro. So I think this could be a really cool pattern for me to add at some point. That's actually relatively easy. I know exactly how to make it happen. Um, the only problem with it is that there's a lot of indirection and usually like performance stuff. And I think it's okay. I know it's okay for like say a Swift application. I don't know if it's okay for a game. Um, I just have to think about it a little bit more. I think it's okay though, genuinely, because I actually now that even now when I'm thinking about it, the interaction only that doesn't happen like every frame, I don't believe. Because it's like when you want to load the sprite, for example, you could, well, it probably does actually, but you could cache it as well. So, and the engine could take care of that. So I think, anyway, I'm just digressing now, but I think there's some really cool opportunities later on to solidify how a game is made. I want to make an entire game, like an actual real game. Could be Asteroids or Pac-Man or something like that. I really like the idea of Pac-Man actually. I want to make one of those games and then say, okay, this works. Then I'll think about those abstractions. But I'm just mentioning that, like, as I see them, that we can discuss them a bit. But yeah, I'm really, really interested in exploring those things later on because I think it would be cool, not because I'm like necessarily trying to like open source this or anything like that. I might, but like more because I want to make the next game easier and faster and make less mistakes and et cetera, et cetera. So basically just to like solve some of those teething problems that might occur or will occur um, very early on now. Sorry, I'm just trying to find. Okay, so what time is it now? 1 o'clock. Can I tell how long the stream's been running? Okay, an hour and 20 minutes. Nice. Um, I'm probably going to stop before starting tile map because I think it's too long and I have to be somewhere shortly. I didn't have as much time today as I thought. I mean, this was good anyway for me to like just get it out of my head a little bit and share what I've been working on. Um, the, I I know this is way too late to say this now. The title is not meant to be clickbaity. It was just meant to like set the tone a little bit. Um, I don't know if that was a fail. It doesn't matter at this point. No one's watching. But if you do see this and you get to the end, let me just say the reason, I think I mentioned it a little bit earlier on in this stream, but the reason I decided to call it Mood and the reason I titled the video the way I did is because I'm not trying to make this run, on a pregnancy test, right? But if I can get this, if I can make these little games and if I can make it run, I know I can make it run on every Apple platform, um, minus probably the watch. Maybe some games on the watch too. Um, but I know I can make it run on most. Certainly Apple TV, which I think is most exciting, at least for my kids, to do some maybe co-op gaming. Um, Definitely on iPad and therefore iPhone. And the Mac I already have running. And actually, I've Vision Pro as well, and that would be interesting to explore. So I think there's like, from Apple's platforms, like I'm covered. I'm really not concerned there. Now that I have web and I know I can upload to itch.io, it means I can distribute to everybody, regardless of your platform, which is a huge initial step, and I'm really, really proud of that already. I think that the reason again to call it Mood as a homage to Doom is because I think I can also get it to run on Windows. And if I can get it to run on Windows, maybe I can get it to run on Steam. I don't know what the difference is there, but I think that there could be a potential opportunity there. And if I could do that, it means that it's on Windows handhelds, not just on Windows laptops, which I think is a big deal. And Steam was also like a perfect playground for indie devs. So I think that would be really, really cool and fun. And if I keep my games simple enough and fast enough that they don't need C, C++, and whatever else, then maybe I can stick this out in Swift for a lot longer than I was originally anticipating. So I think that could be really, really fun. And so yeah, I just wanted to see. It's not so much can I run it everywhere. It's more like how many platforms can I make it run on while still working in Swift. And I think I don't know. There's something about that I feel like is a challenge worthy of my time. So yeah. Anyway, let's see how it goes. I will try and do another live stream tomorrow, but it's going to be 38 degrees here in London, so we'll see. But yeah, if you see this or have any interest whatsoever in game development and Swift and whatever, please do join. I would love to have an audience that I'm actually talking to. And yeah, it'll probably be around midday UK time. I should start to get to know some of the other world time zones because I can't tell you. But yeah, we'll try and do that. And I might have this next milestone largely done by then, so I'll just start from there and cover that. And if not, we can do it together. If I have it, it would be great though, because then we could actually focus on a game and just maybe we could take a look at. I think what we're going to do is sort of review Pac-Man, like open up a clone of it. Or if I think that might be easier, and take a look and think about the levels and how they're designed and set up, how the player movement works, how the rules of the game work, all those things, and then make a plan for like how we want to implement it. Um, like I said, I will use AI, but I think right now my main goal is to use AI to get the engine and the library and the frameworks, whatever, in place. Once we get to the actual game, I really do want to focus more on writing the code myself and understanding what I'm writing, and get into a habit of that. So I think what I want to do really is use AI as like a research, like a Google, right, as a research tool. Have it explain to me how conceptually something should work, or how I should think about it when I'm in doubt. But then I want to sort of spend the time doing that, and so I'm going to try and do that on stream so that we can learn that together in case anyone else wants to learn. And if you already know how to do it, please mention it in the chat and save me a bunch of time. I'd rather talk to a person than I would talk to AI. So yeah, if you're around, speak up. All right, guys, I will end the stream there. Thank you.